Let's try one last problem here. Again, we'll do it using p-values first. We have a sample of 106 body temperatures with a mean of 98.2. Assume that sigma is known to be 0.62. That one sentence that we just read is super important because they told us that we have sigma means that we are going to do a z-test, not a t-test. And it says use a 0.05 significance level to test the claim that the mean body temperature of the population is equal to 98.6. So we're going to test the mean for the population that it is equal to 98.6. So if I were to write that out, that means we're looking at a claim that our mu is equal to 98.6. Well, because of the equal to in this, that means that my claim is actually going to be my null hypothesis here. That means my alternative hypothesis will be the complement, which means it'll be mu is not equal to 98.6. Notice the other information that was given in the problem was above. It's that your sample size is n is 106. Your sample mean was 98.2. They did give you sigma, our population standard deviation was 0.62. They even used the symbol sigma. And they told us their level of significance was 0.08. Again, we're going to use a z-test because we were given sigma and we weren't given a list of data, so we're going to do our test using the stats option. What information did they give us? Well, first of all, we have to input the mean from our null hypothesis. That's why the little 0 or not symbol underneath, which is 98.6. They also gave us the population standard deviation of 0.62. A sample mean of 98.2 in the problem, and a sample size of 106. And last part is always this symbol from the alternative hypothesis, which is a not equal, meaning that it will actually do a two-tailed test for us. We're doing the p-values approach first here, so I'm only going to care when we hit calculate here about the p-value that spits out, even though it will also spit out a z-value. We're only going to be looking at the p-value. So notice when we hit calculate, we get the p-value of 3.10, or it looks like that. But if you keep reading, there's an e to the negative 11th, which means that this is actually in scientific notation. This means that we actually have a p-value of 3.10 times 10 to the negative 11th. What does that mean as a normal number? Well, remember, negative exponents on scientific notation means that decimal place is going to get moved 11 places to the left, which means our p-value is 0.0000000. We're going to get 10 zeros before our 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we'll have our 3. That is a really, really small p-value. Again, typed out, it looks a little bit nicer, is right here. So that's our p-value. Remember, our question is the same no matter what. The question is p less than or equal to alpha? Well, p was 0.0000000, well, 10 zeros, then a 3. And our alpha is just 0.05. So is that p smaller than 0.05? Absolutely it is. The question is, what does yes mean to that question? Well, yes is always going to mean that we reject H naught. Well, let's remind ourselves what H naught was. H naught was our claim that the mean was 98.6. That was our claim. Well, and we are rejecting H0. So, what that means is we can say that there is actually sufficient evidence to do something, because we're not failing to do anything. We're actually doing something here. So there is sufficient evidence to do what? Well, we're going to reject the H0, which is also our claim. So we're rejecting the claim that the mean is equal to 98.6. So there's our fancy answer, is that we actually have enough evidence this time to actually do something. What are we going to do to the claim? We're going to reject it. Now let's redo the exact same problem using rejection regions.